Hey Cal,
Hey Corey, how can I help?
check the TrueNAS status.
Your TrueNAS is running great. Uptime is 41 days with CPU at 7% and 24 of 31 gigs of RAM used. Both storage pools are healthy and 18 apps are currently running.
What apps aren't running?
Looking at the TrueNAS status, OpenWebUI and Homelab are currently stuck.
Can you start Homelab?
Homelab is starting now. I'll let you know if there's a problem.
If you've been following along, welcome back. And if you're new here and unfamiliar with my voice assistant project, CAAL is the voice assistant that I actually wanted. And it's only limited in its capabilities by what I can build in N8N. What you just saw there was CAAL running on my TrueNAS machine with no GPU, triggering workflows in N8N that are interacting with the TrueNAS API. But I also have workflows for interacting with Home Assistant, checking my calendar, even giving me insights into my NFL fantasy. And I'm just getting going on building them. The possibilities are really endless. It's been another busy week developing CAAL. Hey Cal,
What can I do for you?
can you check the GitHub repo?
Your GitHub repo has two open pull requests, one from CMAC86 for version 1.4.0 with GPU free mode and Home Assistant integration, plus another from Maudit adding French language support.
So that PR that Cal just told us about is what's making it possible for Cal to run on my TrueNAS without a GPU. So since I released it a couple weeks ago, people have been asking me about minimum system requirements and really running locally with a local model, local speech to text, local text to speech. You needed about 12 gigs of VRAM at a minimum to run it effectively. And that's a barrier for a lot of people who aren't running a GPU. And I know a lot of home labbers are running older hardware, which is great. So I didn't want that to be a barrier. So what's different in this new release is that Groq is available as a service provider. So instead of running Ollama LLM on your local machine, you can use the free tier of Groq and use it for the heavy lifting, for speech to text, and for the LLM. Second big update is a first start wizard. Makes it a lot easier to get going. You just update one variable in the .env file, then install, do a first start, and you have a graphical interface to set up everything else within the browser. The third thing is simplified Home Assistant controls. When connecting directly to Home Assistant MCP server, it exposes 15 different tools, and it's confusing. The instructions aren't very clear for the LLM to follow, and you get a lot of missed calls, you get a lot of hallucinations. It's a challenge. So what I've done is put a wrapper around those 15 and made two simple tools for CAAL to call. And so far the testing has been a lot more reliable. So now I'm going to show you how to set it up on a TrueNAS machine or a machine with a powerful GPU. So let's get into it. Okay, I'm going to show you how to get going with CPU only on my TrueNAS machine. So I'm going to install it on this machine here. It's got a Xeon E3, 32 gigs of RAM. First thing you're going to want to do is get an API key from Groq. Groq is going to be the service provider for our LLM and for the speech to text. So go here to console.groq.com, log in, go to API keys. Really easy. You get a free tier, which is pretty generous. Now I'm going to log on to my TrueNAS machine through SSH. Okay, and the first thing I'm going to do is clone the repo. Okay, and go into that folder. And I'm going to switch branches because I haven't merged it yet, but you won't have to do this. And then we just want to copy the example.env to our own. And then open up that .env and scroll down. And the only thing we need to edit for now, maybe ever, is the IP address. So put in the IP address of the machine you're installing this on for both the CAAL host IP and for our HTTPS domain. You can set this up with Tailscale. There's instructions here how to do that, but for now we're just going to use it locally with HTTPS. So Control-O, Control-X, and then we're ready to install. So we'll do Docker compose, and we're going to use the file, specifically this Docker compose CPU file. So this is going to install it for CPU. It's not going to pull down the big images for Kokoro and the speeches, CUDA enabled images. It saves about 17 gigs of space by using this. And then we're also going to use the profile HTTPS, and we'll say upd. Of course, I need to do sudo. And then we'll wait for all this to pull down and install. If you're doing this on a local machine, you don't have to use HTTPS. You can just access through your web browser through localhost. But because this is on a server and we're going to be accessing it through other machines, and browsers only allow the mic to be used through secure connection, that's why we need to use the HTTPS profile. And with that profile, it'll automatically create certification files for us. You will get the warning that this is unsafe, that you can click through in the browser, which you'll see in a minute. You can get around that by creating your own cert files and replacing them, but this makes it easy to get up and going. Okay, it's all built. It takes a little bit to get through all that. On the dev path is getting images pre-built and up on Docker Hub. So you're just pulling an image instead of building the agent and the front end on your machine. That'll speed things up a bit. Just not there on the development yet. So let's try to connect. Flip over to our browser, open a new tab, and it's running at 3443. And so first launch, you're greeted with this new startup wizard. This is where we choose our AI provider, our speech to text, our text to speech, and our integration. So connecting to N8N and Home Assistant. So we're CPU only. We're going to use Groq, and you'll have your API key, and put it in here and test the connection. And it's connected, and we can select a model. I've been playing around with this Kimi K2. When selecting Groq, it's going to use Groq for your speech to text as well. It runs a faster Whisper V3 Turbo. And then if we go to the next step, we can select our voice. And because we didn't install Kokoro, we went CPU only, we'll select Piper. I'm going to select this Ryan, higher quality, hit continue. And this is where we can connect to Home Assistant and N8N workflows. So first, I'll connect to Home Assistant, which for me is there. I'll grab my key, put it there and test that, connected. And now for N8N, for me it's running there. Grab the key. No, wrong address. There we go. And when I click finish setup, it's gonna download the voice model that we chose, that Ryan high quality. Now we're ready to test it out. Allow the mic.
Hello, ready to help with whatever you need.
Hey Cal,
What can I do for you?
turn off the office lamp.
Office lamp is now off.
Turn it back on.
Office lamp is now on.
Okay, so it's working. Let's test a N8N workflow. Hey Cal,
What can I do for you?
check the NFL scores.
Bills 20, Jaguars 24, fourth quarter. Rams 34, Panthers 31, final. Bears 31, Packers 27, final.
I should be really watching those games instead of recording this, but here I am. Okay, so you'll notice that whenever it's using a tool, it's showing you down here which tool it used, and if you click this, it'll show you the parameters that it sent as well. This one requires no parameters, so it doesn't show any. And wake word is enabled by default, but if we end the call, and we now go into settings, there's a few more options here that aren't shown in the wizard. So every time you trigger the wake word, it picks one of these wake greetings at random. You can add whichever ones you want here. I find Piper doesn't do well with these single word responses, so you may want to get rid of some of those. Kokoro handles those better. You can select your voice. You can go into your prompt. This is the default prompt. that I've created. You can click custom and edit it or delete it and create your own. And when you hit save, it'll save that into a custom file, and you can always switch back to the default if you want. Providers, if you want to change this up, you'd have to rebuild with a different profile, but then come in here and select Ollama if you want to do that. Change your model if you want to continue using Groq, but change your model. Go to Kokoro speech, text-to-speech. In the LLM, you can change some of the settings here. So the temperature, how much context you want to provide. This is a Ollama setting specifically. Max turns is how many turns in the conversation are kept before it pushes the old ones out. So first in, first out. Same as tool cache size. The tool cache size is how many tool calls worth of data it keeps in context before it pushes the old ones out. So 3 tool calls worth of data. So what it gets from the N8N workflow as it returns is a message that it reads out, but then it has extra data along with that that can be used for follow-up questions. So when I asked about the TrueNAS status, it gave me a message about CPU usage and RAM usage, but then I did a follow-up question, what apps are not running, and it used that cache data to answer that question and didn't have to do another tool call. So this is all, these 2 settings are about managing the context. Then down here, turn detection, allow interruptions, yes or no, and then the delay before it detects that you're done speaking. So that's your turn detection. So if you have a pause in your speech, you can increase this so that it doesn't think that you're already done talking. And then integrations, this is the same as the wizard. And then wake word, this is where you can enable or disable wake word and change which model. It's just shipping with Hey CAAL and Hey Jarvis right now. And the threshold, how easily it detects. And then the silence timeout after you say Hey CAAL or after it responds, how long before the wake word kicks back in again. Okay, and then I'll just quickly show you an example workflow. This is the one I called earlier to get the TrueNAS status. So each workflow looks very similar where you have a webhook and a respond to webhook. You can get more complicated where it responds to a webhook, continues on with some other logic, and then does an announcement later. I'll show you that in a second. But the convention we use here is that the name of the workflow, let me zoom in on the interface a bit. The name of the workflow matches the webhook URL. That's how it discovers these workflows through MCP. And within the settings of that webhook, the notes is the instruction to the LLM on how to use the tool. Then this one does some logic calling API of TrueNAS to get all the different information, merges it all, formats a response, and then sends that back to CAAL. So if I look at a recent execution and open up the response, this is what it looks like. So this is the message that it spoke aloud. And then here's all the other information that comes along with it. System, the pools, the apps. So when I asked, hey, what's not running? What apps are not running? It looked through this data and said, Open Web UI is stopped. And at that time, Homar was stopped as well. And then when I asked it to start Homar, it called this other workflow right here. And this one's a bit more complicated because I have a loop where it's checking if the app has actually started. So let's zoom into this. So same convention, the name of the workflow matches the path of the webhook. The instructions are here. So control TrueNAS app, start, stop, or restart. The parameters are app name and action. And then you could just have this as the workflow, respond to the webhook, and then be done with it. and assume that the app is gonna start, or you could get more complicated with it, which is what I've done here. And it checks for the job ID, and then it starts polling that job ID to see what the state of it is. It checks the status of it, checks the app status, and then it goes into a loop checking that every 10 seconds until it starts. If it hasn't started within 2 minutes, it calls a CAAL webhook, which is the announce webhook, and it'll say, hey, the app hasn't started, it's been 2 minutes, you might want to check on it. So there's some workflows already in the repo to get started, some examples. I'm going to create some more and share them with people, and my hope is that people who are using CAAL can create workflows and share them with others as well. So I'm going to be setting up a designated repo to do just that, where we can share workflows with each other. So that's CAAL 1.4 release today. Big release for me. It's been a lot of work getting the Groq implementation in place for people who don't have GPUs that can run this. The Home Assistant tool simplification to make it easier to trigger tools from the voice assistant, and the startup wizard, which just makes configuring it all that much easier. I think there's a lot of potential here, and people who are creative with N8N workflows could do some pretty cool things, I think, with this. So if you are doing that, please share your ideas on the GitHub discussion page. I'm gonna set up that repo, like I said, to share the workflows. I'm really curious what people will come up with. And next on the roadmap for CAAL, I'm looking at putting in place some ESP32 satellite devices. So I have this right here, this prototype little board. I'm going to see if I can get this to work as a device. For now though, if you want, you can use Android tablets, and check out this video here on how to install the app. There'll be a version 1.4 available in the releases section of GitHub as well, an APK that you can put on your Android device and use it as a satellite. And I'm also going to be working on giving CAAL a long-term memory. That's upcoming. Stay tuned for those releases. Thanks for watching this one, and we'll see you in the next.